Okay, I'm going to go through the solution to number 13. This is the solution that appears in the period 2 scans. I think it's actually the period 4 solution. The red die and the blue die, and you've got this weird way of calculating the sum on the two. If if the if the red die is even, then you're going to add on 2 times whatever the blue die gets. So double the blue die is what it says. If the red die is odd, so 1, 3, or 5, then you're going to add on half of what the blue die is. So to come up with this entire table, what you see in front of you here, in our normal 2 die example, this would have been the sums, and it would have started at 2 and gone all the way up to 12. And we've done that a few times. But we're going to fill in the table with the sums based on these rules that are provided. So for example, I started when we did this with the group in the class, we started with the even numbers 2, 4, and 6 on the red die. So that's over here on the rows. So if I roll a 2, I'm going to add on 2 times of whatever the blue die is. So for example, if I get a 1 on the blue die, that means I'm going to double it. So 2 plus 2, I get 4. If I get 2 on the blue die, I'm going to go 2 plus 4 because I doubled the 2 and I got 6. If I roll a 3 on the blue die, I double it, I get 6, and I add 2 on, I got 8, and so on. So if I roll a 2, these are the possible values of getting a 2 on the red die, and these are the possible sums: 4, 6, 8, 10, 12, and 6 and 14. Same thing for 4. If I roll a 4, that's an even number. I double whatever I get on the blue die. So if it's a 1, I double it, it's 2, so 4 plus 2 is 6. If it's a 2, I double it, 4 plus 4 is 8, and so on. So I got 6, 8, 10, 12, 14, and 16. Similarly, if it's a 6 on the red die, again an even number, I double whatever I get on the blue die. So 6 plus 1 doubled is 8. 6 plus 2 doubled is 10, and so on all the way up to 6 plus 6 doubled, which is 12. 6 plus 12 is 18. Now for the odd ones, 1, 3, and 5, we're going to add on half of whatever is on the blue die. So starting, for example, with 1 on the red die, I add on half of 1, which is 0.5, and that's where 1.5 came from. If I get 1 and then 2 on the blue die, half of 2 is 1. 1 plus 1 is 2. So basically it goes up by 0.5 this time. So all the way up to, imagine I got 1 on the red die and 6 on the blue die. Half of 6 is 3. 1 plus 3 is 4. Continue with that for 3 and for 5. For 3 and if I roll a 3 on the red die, I add on half of whatever I get on the blue die. So again, either it's going to be 0.5 if it's 1, 1 if it's 2, 1.5 is 3, all the way up to 3 if it's 6. So 3 plus 3 gives me 6. What if I got a 5 on the red die? Again, I add on half of whatever I get on the blue die. So it starts at 5.5 and it ends at 8. Just again to show you how did I get 8 here. I would have got 5 on the red die plus 6 on the blue die, but half of 6 is 3. 5 plus 3 is 8. Now, those are all of the outcomes for this game. I can finally start calculating the expected values. So that's where the rest of the solution comes in. We have to list out all of the possible values you can get in this game. So if you start going through the entire table here, starting at the lowest possible value, 1.5, it comes up once. 2 comes up once. 2.5 comes up once. 3 comes up once, so it has a probability of 1 out of 36. 3.5, however, comes up twice. Okay, 3.5 comes up twice, so it comes up 2 out of 36 times. So if you look at the table that was being generated, 1.5, probably you get that as 1 out of 36. 2, 1 out of 36. Sorry. Nope, I went too far. There it is. 2, 1 out of 36. 2.5, 1 out of 36. 3, 1 out of 36. But look at 3.5, that's a 2 out of 36. 4, if we go up to the table, how many times can I get a 4? I can get it 1, 2, 3 times, okay, if you look at for all the 4s. The reason that they're circles is we were trying to keep track of the total number of the totals as we were going along. So we were circling them as we were counting them. So 4 came up 3 out of 36. So we continue doing this all the way down, okay? So it goes all the way down to 6, continues down 6.5, 5.5, 7, 7.5, 8, but we weren't done. We had to continue in the next column. There's 9, 9 doesn't come up, 10, 12, 14, 16, and 18, and the probabilities are in the next column. So this is 2 separate columns, okay? Once we had the values of the random variable, so which is x, so 1.5 all the way up to 18 here, and then the probabilities that were based on how often they came up in that table, we multiply x times p of x, and that's what this third column is. So 1.5 times 1 over 36 is 1.5 over 36. 2 times 1 over 36 is 2 out of 36, and so on, all the way up to 18 times 1 over 36, which is 18 out of 36. Add that column up, and you get 283.5 out of 36, which is 7.875. So that's the expected outcome for this weird kind of point scheme, which is different from the answer in the back, which was incorrect. So this is correct. I had it done by both groups in the morning and afternoon. They got the exact same answer.